Dr. Yanhong Zeng is a young researcher at Shanghai AI Lab. Before that, she received her PhD degree at Sun Yat-sen University under the joint PhD program between the MSIA in 2022. Her research interests include image and video synthesis and editing, multimodal language and vision. So you can start now, Yanhong.
Okay, thanks for Wenwei's introduction. Now, I'm going to introduce our open source library, MMagic, for the research of multimodal, advanced, generative, and intelligent creation. So the first question is, why should we use MMagic? Specifically, originated from editing, the library has supports many different low-level tasks, including image matching, image deep blurring, and image super resolution, also for image colorization, and also for the task of video enhancement, including video frame interpolation, which can make your video more smooth, and also for the task of video super resolution, which can convert your video into higher quality. I think these techniques have been widely applied in our daily lives. And the library has supported the community users to 10 champions in the top academic challenges. Besides, the library also supports many different generative tasks, including the image generation by style gun, and also for the novel view synthesis by AG3D, and also for the recent popular topics, including the text-to-image generation by latent diffusion model, and also for the subject-driven image generation by Dream Booth. And we also study the controllable image generation, which can control the foundation text-to-image model by adding more control conditions. And also for the text-based video editing and the generation task. In this case, we use ControlNet to guide the video editing or video generation process. And then we use multi-frame rendering technique, and also sometimes we use attention injection technique to ensure the video coherence. Yes, with more condition based on the text-to-image generation model, we can re-render the input video from photorealistic style into a cartoon style. And then with the powerful segment anything model, we can specify any region we want to edit. In this case, we specify the backgrounds and then we replace the backgrounds in the video. So in a word, MMagic is an open source library that has supports many different generative models. And with these powerful generative models, MMagic has supports more than 20 tasks, involves more than 50 algorithms. It provides more than 200 configuration files for easy training and testing models, as well as 200 pre-trained model weights. I think MMagic has provides unified user experience to easily test and train state-of-the-art research works for various tasks. So if you are starting on low-level tasks, or generative models, including diffusion models, or combining them together, don't hesitate to use MMagic to help your research. And then the second question is how to use MMagic. Now I will briefly introduce the overall design of MMagic. As we know, there are several important components in a deep learning framework. First, we need to specify the dataset we used for training and testing. Then we need to design our network architecture and define the training loop in model. And then we also need an evaluator to compute the performance metric of different models. Also, the evaluator can help us save the best performance checkpoints during training. And we also need an optimizer to update the model parameters, and also a scheduler to update the parameter in the optimizer. All these things are controlled and organized by a runner in MMagic. And we use Hook to easily plug and play customized optimization in these data flows. We also support easy-to-use logging module to record any information during training and testing, and a visualizer to visualize any images or videos we want to visualize. So all these things can be specified or set in a configuration file, and different modules are managed by the registry mechanism. And now I will here are some installation guidelines. Users can actually to play with MMagic, we need to install PyTorch, MMengine, and MMCV. And here is a simple installation guideline by installation from by me. And also, if you want to experiment on the latest development developed version of MMagic, you can also get clone the source code and install from source code. So to quick start generative AI with MMagic, here I will go through 4 classical examples to play with stable diffusion. They are play with stable diffusion, speed up stable diffusion with Tomi, and customize stable diffusion with Stream Booth. And the last one is control stable diffusion with ControlNet. So here is the first example, playing with stable diffusion. And let me briefly introduce stable diffusion. So stable diffusion is a latent diffusion model which enables people to input a text prompt to generate any images they want. So a classical stable diffusion consists of 3 important components, as you can see in this framework overview. In the pink region, this is a VAE model. It is used to encode images into latent and then decode the latent into image. And we can see in the green region, it's a denoising unit network used to denoise noisy latent. Specifically, in the latent space, there are 2 classical processes. The first process is diffusion process, which can add noise into the latent to a noisy latent, and finally come to a Gaussian noise. And then in the denoising process, the denoising unit is trained to denoise from a noisy latent, so that people can sample a real image from a Gaussian noise. And in the third part is the conditioning module. Here, the authors list several conditions, including semantic maps, text and representations and images. And in a stable diffusion, it typically uses a cliff text encoder to take the text as input and encode them into text embedding. And then Stable Diffusion use classifier-free guidance to sample to guide the sampling process, so that the final generated image will accord to the input text prompt. I think maybe the introduction can be some kind of complicated to guys who are not familiar with the Stable Diffusion. However, using MMagic, I think playing with Stable Diffusion can be very easy. So to play with Stable Diffusion, we need to first initialize the working scope as MMagic. Actually, you can initialize the scope into other library like MMDAT, MMPose to easily use other libraries in OpenMMLab family. And then to use Stable Diffusion in MMagic, you have 3 different ways to they are from Python code, from provided configs, and from influencer. Let's first start from play Stable Diffusion from Python code. It means that you can easily set everything in a Python code style. You can set like the pre-trained model name or path, and then define the diffusion scheduler as a dictionary. And here we define the diffusion scheduler as DDIM scheduler and other arguments. And as we introduced before, there are 3 important components in Stable Diffusion. Here we can set the settings of UNet and VAE, and also the text encoder in the model. So after you specify every details of Stable Diffusion in the Python code style, you can easily build a model from the directory. Here, we can import from MMaigc. We can from MMaigc import models, and here models is a module manage different models built in registered in MMagic. And so after build the Stable Diffusion, we can put the Stable Diffusion model to GPU, and then we call the infer function and import the text prompt. It can directly generate an image according to the prompt. So this is the first way to play with Stable Diffusion. And in the second way, we also provide some classical default configuration files in our project. So you can easily read and load the configuration file from this path. And after loading the configuration, you can build from the configuration as we did in the first way, and we can obtain the same result. And if you think it's hard to define everything in detail as the first way and in the provided configs way, we also provide the third way to play with diffusion. In this way, there are only 5 lines of code you can run the Stable Diffusion. First, you need to initialize a MMagic influencer, and you need to specify your model name as Stable Diffusion. And then you need to specify text prompts and the result directory, and input these 2 arguments into the Stable Diffusion influencer, and now you can get the result in the target directory. And now we have presented 3 ways to play with Stable Diffusion in MMagic, but many users are suffering from long influence time of Stable Diffusion. So many researchers have studied on improving the efficiency of Stable Diffusion. Here we present Tomi. Tomi is a technique that is designed to merge redundant tokens in each attention operation. In this illustration, compared with transformer unit block, we can find that with token merging in each operation, we will merge similar token before the attention calculation, so that the attention calculation can be largely reduced. So we can reduce the overall influence time. To use Tomi in MMagic is very easy. Here we can still start from the classical Stable Diffusion configuration. Here, yes, we load from the Stable Diffusion configuration file, and we print the content, and we can find that here are some classical settings, including UNet, VAE tokenizer, right? And then we only need one line to enable Tomi. We only need to set the model's Tomi SD configuration and set the ratio as 100%. It means it is a ratio parameter to decide how many tokens do we plan to merge during each merge operation. So after modify the setting, we use the same build and influence pipeline to sample a new sample. And here is a table to compare Stable Diffusion with or without Tomi, and also compare different ratio, different merging ratio, and their and their corresponding efficiency improvement. There's no free lunch, so the large influence reduction comes from the reduction of performance, and we can see that when we merge more tokens, the image quality will decrease. And then the third example is to customize Stable Diffusion with DreamBoost. DreamBoost is the work to fine-tune text-to-image diffusion models for subject-driven generation. This task aims to generate new concepts provided by users' input image, because when we use a pre-trained large text-to-image generation model like Stable Diffusion, we cannot generate the exact personal object, such as my pet dog or my personal toys. So here, DreamBoost enables such a task by fine-tuning the pre-trained text-to-image generation based on the provided user inputs. So in fine-tuning stage, people only need to provide several images, and after training, we can generate the pet dog in new surroundings and in new styles by editing the text prompt. To customize Stable Diffusion with DreamBoost is easy in MMagic. Here we still start from the default stable diffusion configuration file. We load the configuration file of stable diffusion. And to enable Dream Booth, there are 3 steps. The first step is to change the model type into Dream Booth. And then we need to specify prior loss weight and class prior prompt. Take the pet dog as an example. Here we need to specify a dog as the class prompt, so that during training, we fine-tune the pre-trained text-to-image generation model, but it will not overfit to the pet dog. It will also remember other kinds of dogs. And typically, the original Dream Booth implementation will fine-tune all the model weights. And here in MMagic, we also support Aurora so that you can conduct efficient training for Dream Booth. Here you only need to train much less parameters for a comparable performance. And here to enable Aurora, we only need to set the Aurora configuration in the config model. And also, now you can influence your Dream Booth with pre-trained model weights. But if you want to train your own Dream Booth, you need to specify the pipeline, the dataset, and data loader, and other configurations listed here. And also the optimizer and some hooks that help you to better manage the experiments. And finally, you can use such a line of script to start your training. If you see this information logging in the console, and I think you have successful begin your training for Dream Booth. And here are some training information during during your experiments. And here are some results produced by MMaigc. And finally, comes to the example of controlling stable diffusion with ControlNet. Actually, the original stable diffusion can only generate images according to the input text prompt. So ControlNet is a very great work that changes the games. It enables input different conditions to control the generation, such as the detected canny edges and the human pose. So how to control stable diffusion in MMagic? Here comes the example. We provide classical default ControlNet configuration file in our projects. So here we load the configuration file of ControlNet, and we can see that it follows the overall architecture of the original stable diffusion. Here VAE, UNet, text encoder, and here we just add a set of settings for ControlNet. We need to specify the ControlNet's model name as ControlNet model, and we provide the pre-trained path for the ControlNet weight. And we also need to set the type of initialization configuration for the ControlNet model weights. Here we choose the convert from UNet because we here in the VAE and UNet we didn't use the default stable diffusion weight. we use some checkpoints from the community. So we need to set the initialization configuration as convert from UNet. So after the configuration, here we need to provide some conditions such as the human pose. And then we build from the configuration and to create a ControlNet model. And then we input prompt and call the infer function of ControlNet. And then we can obtain a generated image. Yes, I think they have the same pose. So if you want to train your own ControlNet, you still need to set these things, including training configuration, optimizer, and the pipeline used to process images, and the dataset, data loader, and finally the script to run your training. Yes, I think that's all for my introduction to MMagic.